Greetings to all panelists. My name is Lee Gong Fa. I am a presenter from Polytechnic Kuching, Sarawak. The title that I am going to present today is a comparison establishing control points by using static and real-time kinematic methods. Introduction. A comparison between the static and real-time kinematic RTK methods for establishing control points is an important method in the field of surveying and mapping. The static method of establishing control points involves placing a global navigation satellite system receiver at a point for an extended period of time to obtain highly precise measurements. Real-time kinematic RTK is a method of establishing control points that involve using a global navigation satellite system receiver and a base station to provide real-time corrections to the measurements taken by the rover. Both of the static method and the RTK method can be used to establish control points, but they differ in terms of the time required to obtain precise measurements and the equipment required. Problem statement. For the majority of surveying and construction projects, a high level of global accuracy must be ensured. Hence, the accuracy of the ground control point is important. The choice of method depends on the specific project requirements. Both the static and RTK methods have their own advantages and limitations. Objective: to compare the establishing control points by using static and real-time kinematic methods. To understanding the difference of the static and real-time kinematic methods in selecting the method for establishing control points. Literature review. Acquisition of ground control points is particularly important for geometric correction of high-resolution satellite image. One of the most efficient and easiest way to establish the three-dimensional positions of the ground control points is to use global navigation satellite system technology. Static global navigation satellite system surveying is a reactive positioning technique that depends on the carrier phase measurements. Methodology. For the static method, a global navigation satellite system receiver is placed at the point of interest and allowed to collect data for an extended period of time, usually several hours. The RTK method involves using a global navigation satellite system receiver and a base station. Equipment. Topcon Hybrid VR is an equipment to use for a data collection by using a static and real-time kinematic method. Topcon Hybrid VR is a complete equipment and can be used in many ways. It can be used for static or kinematic global navigation satellite system post-process surveys. Equipment accuracy of this equipment by using real-time kinematic is 5 cm for horizontal observation and 10 mm for vertical observation. The location of the research is at Polytechnic Kuching Sarawak campus. PKS 20, PKS 30, PKS 40, PKS 50, and PKS 80 selected as a ground control points. SS7064 selected as a non-control point. This is the surveying plan for the ground control points of PKS 20, PKS 30, PKS 40, PKS 50, and PKS 80. This surveying plan is processed by using AutoCAD software to show the location of the ground control points. This is the source data that collected by real-time kinematic. Station SS7064 selected as a base station and ground control points of PKS 20, PKS 30, PKS 40, PKS 50, and PKS 80 selected as a rover for the real-time kinematic method. The data will process on the spot using the TopCon Hyper VR equipment. This data will be to compare the different coordinates of the control points for the accuracy comparison between the real-time kinematic method and static method. This is the source data that collected by static method. Station SS7064 selected as a base station and control points of PKS 20, PKS 30, PKS 40, PKS 50, and PKS 80 selected as a rover for the static method. The computer software is used to analyze the data by using the Kinematic tools software. This data will be to compare the different coordinates of the control points for the accuracy comparison between the real-time kinematic method and static method. Results and discussion. This table shows the coordinate of the control points between static and real-time kinematic. This table also shows the different coordinate between static and real-time kinematic methods for the establishing of the control points. From the result of research finding, it is shown that the coordinates of control points between static and real-time kinematic is almost same. According to the guidelines on the use of the Malaysia RTK Global Navigation Satellite System Network, the accepted accuracy of the error found is 4 cm. Based to the result finding, the difference between the real-time kinematic method and static method is meet the set of the accuracy limits. Conclusions. Both of the static method and the RTK method can be used to interpret the control points, but they differ in terms of the time required to obtain precise measurements, accuracy, equipment, and application requirements. The comparison between the static method and the RTK method for establishing control points has shown that both methods have their advantages and disadvantages. Overall, the selection of a suitable method for establishing control points should be made after an analysis for the application requirements. Thank you.